Alright, so we have the following setup. We have the distance sensor. We'll use the distance sensor to record the distance between any object and the sensor. We also have the LED. We have a speaker. The speaker is connected to pin number 3. The LED is connected to pin number A1, also known as digital pin number 15. And the distance sensor is connected to pins number 2 and 4. The TX of the Wi-Fi module is connected to number 7 or pin number 7, and the RX is connected to pin number 8. So let's connect this. Let's check the settings. So we have the board as Arduino Nano. Processor is either 80 Mega 3280p. If it doesn't work, use the old bootloader. Whichever works, that's it. And for the port, it's number 15. In this case, you may have a different port number on your computer. I'll select 15, and then I'll download the code or the template for writing. It should download to your computer, and I will also download the other template for reading. I'll open the template first for writing. I'll copy everything and put it in the IDE of Arduino. So I'll erase the standard template, replace it with the code that I just copied. I have to make sure that the following libraries are installed. So make sure the Wi-Fi ESP is installed. In my case, it is. I will also check the ThingSpeak is also installed, which is the case on my computer. So first of all, let's specify the network or the Wi-Fi network. I'll be using the local network, the local 2.4 GHz network, R0B0T1CS. The password is R0B0T1CS. This only works in the laboratory. And then what will happen is I will use this function to get the reading from the distance sensor. So from the very beginning, I have that variable for the sensor. And for the channel number, I need to log into my ThingSpeak account. I'll make a new one. So in my channel, I'll name it IoT demonstration, and I will use two fields. For the first field, I'll use it to store the reading from the distance sensor. For a second field, I'll use it as a switch. It will store values depending on what I want to happen later. So don't forget to save. And I will also select sharing and enable channel view to everyone. So that it will be available in public. Okay, so starting with the distance, I'll go back to the code. Okay, so I'll copy the channel number. Channel number is 2005524 in my case. And then I need to indicate the API keys, which will serve as passwords. I'll click the API key tab. I'll copy the key for write and put it here. I'll also copy the read key to there. And let's work on the data for distance first. This part of the code will compute for the distance, print it in the serial monitor, and this code or this line will save it in channel number 1. And this will allow us if the update is successful. I'm going to upload. I'll save it later. And uploading, let's open the serial monitor. Make sure that the setting is 105/200 for the baud rate, and you should be able to see the messages. This reading is 4.53 centimeters. Let's check our chart. Okay, according to the message, it was not a success. So let's wait for it to do the same update or the same process, but a different value should be stored instead. So let me refresh. So it's there. So the reading should be 4.12. Okay. So let's check again. There should be another reading. Let me just make changes. Let me move this bit. After several updates, we should be seeing the details of the different values that have that were saved here in the chart. We can also make a widget by clicking add widgets, and let's use a lamp indicator and select condition. say the name of the widget is distance, and I'll make it turn red if the distance falls below 5 centimeters, but is less than 5, and the update will be done every 15 seconds. Create, and it's there. Current reading is 10. Put an object in front of the sensor. The reading should now be less than 5 centimeters. Let's wait for the update. So that's 3.5. Update was a success. So if you will check, we should see that the widget should display a red lamp, or the red indicator should be switched on. If I will remove the object, get a value which is greater than 5. Let's just wait. This reading is at 10 centimeters. Update was a success. Let's refresh, and that's it. The indicator has been switched off. Next, we'll make the LED switch on and off by changing the value stored in the switch chart or switch field. We'll do it manually. So to do that manually, we are going to go to the API keys tab, copy this link, open it in a new tab, and paste the field number 2. Let's set it to 0. After pressing enter, we should get a record number. This should be greater than 0. If you get 0, meaning that would not be a success. So all you need to do is just to do it again. So let's check if the value was saved. So it's there. So if I change it to 1, so we got 0, so that is not a success. So let's just do it again. I'll press enter. 0 again. So just keep on doing it until you get a value which is greater than 0. There you go. And then I'll probably change it to 2. Do it again. So this happens maybe because the server is busy. Let's just try again. And there you go. So let's check. We should be getting numbers 0, 1, and 2. So that's 0, 1, and 2. And we'll use this to make the device switch on the LED based on the value that is stored in the field, which is field number 2. So let's go back to our code, and what I'll do is I'll create a variable for switch. SW is equal to 0, and I'm going to set the pin mode for the LED to output. But first, let me just here. LED is equal to 15. So 15 is also known as A1. And then I'll do the same for the speaker. And it's currently connected to number 3. Under setup, I'll set the pin mode. For LED, I'll set it as output. Same with the speaker. And from the very beginning, I'll switch off both LED and speaker. I'll set them to low. And here, after writing, I'll make the device also read. I'll open the code for reading, and I'll copy the code or the lines that will allow me to read from the database. Here, I'll copy this part up to that line. I'll copy. I'll go back to the code and insert it there. I'll put it here. So after writing, I will make it read, and I'll use the same variable SW, and this is the code for reading. So this refers to channel number 2, and you have to indicate your channel number and your API key for reading. And here, I will erase this part, edit it, and make the device do the following. So if SW is equal to 0, then I'll make it, I'll switch on the LED, digital right, I'll switch it off. I'll switch off the LED. LED is low. It's 1. I'll make it go high. The LED should switch on. For the speaker, I'll make use of 2. Keep it off. And I'll make use of 3. To switch it on. You decide how you want to use the code or what code you will use. Following code, I'll use 0 if I want to the LED to switch off, 1 to switch on the LED, 2 to switch off the speaker, and 3 to switch on the speaker. I'll upload it. And then let's check serial monitor again. And then I'm going to manually change the field number, the switch field to number 1. Switch on the LED. Just wait. Okay, so this wasn't a success. So I'll do it again. again. Server may be busy. Let's try again. Okay. The next reading, we should be getting 1. So that's the distance, followed by a reading, which would be 1. And we're not able to read, so let's wait for the device to try again. So that happens every 20 seconds. Okay, so LED has been switched on. So what I'll do now is I'll change it to 0, switch off the LED. So we get 0, let's try again. Then let's check. This should switch off in the next reading. Let's wait. Okay, so it's off. Let's switch on the speaker this time. Off. I'll use number 2. Let's try again. And there you have it.